So let's talk about the intermediate value theorem, okay? Let f of x, be continuous, right, which we've now defined, over a closed bounded interval. If z is any real number if there's at least one number c in that interval satisfying f of c equals z, that means that f will take on a value on every value between f of a and f of b on this interval. There's a limit form of this theorem, right? This says for any limit between f of a and f of b, there exists a number c satisfying f of c of L. Okay, so this can be done via graphs, and we can also see it if we define an interval this way. Now, I want to talk about this some more. So, what this means is for any limit between f of a and f of b, there exists at least one number c in AC for which f of c equals L. Okay, so let's sketch this out. I feel like we need a more graphical representation. So let's say I have a function. Here's a, here's b. That's a beautiful function. And I've got a value c. That's saying that if that exists, right, then for any, here's f of a, right, my y, and here's b, f of b, that there exists an f of c which is L all along this interval. And this is true because we say that it has to be continuous over this closed interval AB. So this is always going to be true. So if I had, here's my graph example. So if I have f of x be a function continuous, where f of negative 2 is 3 and f of 1 is 6, so there exists a c between negative 2 and 1. So that means I'll have f of negative 2, which is less than f of c, which is less than or equal to f of 1. That means I have 3 is less than or equal to f of c, which is less than or equal to 6. So I'm just going to take on some value in that interval.